Happy Halloween, nerds, and welcome to CTF and Cigars.
Okay, back to normal. So yeah, welcome to CTF and Cigars. I'm Bammed, and this is the show where I smoke a cigar and talk about CTFs. This week, I'm bringing back one from a couple weeks ago. I've got the Drew Estate Maduro. So that's a nice dark cigar. So this is the Drew Estate Undercrown. Not sure what I just said a minute ago, but yeah, it's the Undercrown Maduro Robusto. So the Robusto is the size, it's 5 inches, 54 gauge. This is a medium to full body cigar. It's got a dark San Andreas Mexican Maduro wrapper with the Connecticut and broadleaf binder, and then the Brazilian and Nicaraguan filler. It's got a nice sort of earthy hay, grass, a little bit of cedar smell to it. And then when we light it up, I've had several of these, but yeah, I'll tell you what it's like. It's got a bit of an earthy taste to it, more that earthy and cederness, but then it's also got some that Maduro brings in some dark espresso and cocoa flavors. Is pretty nice. And then once you get into it a bit, the cedar sort of backs off, and you get some more chocolate, and actually gets more into like white chocolate. So this is a pretty nice cigar. It burns nice and evenly all the way through. Good amount of smoke. Very enjoyable. I've had a lot of these. Decided to have another one this week. So this week I've got a special guest. Let's bring him on. I apologize, but I am having some trouble with OBS today, and it seems like every 5 minutes his camera keeps resizing, but here we go. We've got Taylor. Taylor, introduce yourself.
Hey, I'm Taylor Green. I'm the director of Perch Security, and I like to do CTF stuff, so just jumping on to show off some Crackmes and maybe some beginner level Crackmes and kind of show people how to take a look at these and figure out what you want to do to get through them. So a lot of beginner level stuff. Not going to go through anything that's like medium or hard here, but yeah, just some simple Crackmes.
Nice, thanks, Taylor. Oh, and I think you may have noticed the title of this episode was Crackmes with Taypop. So Taylor, why do we call you Taypop?
Well, I unfortunately let somebody else write my bio at one point. Before I was giving a public talk, and they wrote into my bio that I like to make music in my free time, and I'm a part of a band called Taypop. So that kind of stuck. People just call me Taypop now.
Yeah, that's always fun.
Amongst other things.
Yeah. All right. Excuse me, I'm having technical difficulties here. My earbuds fell out. So, all right. Well, let's jump into some Crackmes then. Taylor, you've got a couple of Crackmes you've got from Crackmes.1, isn't it? That's right.
Correct. Correct. Yeah, I got all these from Crackmes.1. There's 4 of them in total. 2 of them are on Mac OS, and 2 of them are on Linux. So we're going to start off with 2 on Mac OS first, and then we'll hop over to Linux. The easiest one first here. So I don't know if you can see my screen.
Yeah, we can see it. Or at least
cool. All right, so I got cool. So I got 2 of them right here. Guess my name and past version. So shout out to the guys who made these over at Crack One. I unfortunately do not have their usernames right here right now, but much appreciated. So just to kind of start off, the first thing I usually like to do is figure out what kind of file that I'm working with. I didn't actually know that these were Mac OS or Linux until I actually ran some commands on them. So I was looking to see what, I believe it was file, right? So we can just do file. We can see here that this is a Mach O, which is Mac OS. So same thing with the other one here as well, the past version. You'd be looking for that, or you're looking for like an ELF file or an MZ file or something like that. Kind of figure out what operating system you need to be running this in if you're going to be debugging it. So for this one, obviously, we're just going to be on Mac OS. So A couple other things I like to start with on this, and I'm going to start off with just the easy stuff first, which is I like to run strings on them first, just to kind of see what I can view about them, and I like to just run them to see what they do. Kind of understand the program first. So we'll start off with guess me here, or guess my name. So it asks what's my name. So a couple of things to pay attention to here is like how it is that the program itself behaves. Once I run this, I know that it doesn't take a command line. Sorry. I'm sitting right next to a road, a little loud. Sorry about that. But the right here, it's going to pop out what's my name. This gives me kind of a pivot point in the program as well. And I also know that it's not taking in any arguments here. I know that everything's happening inside the program. So it's also asking me what's my name. I'm going to ASDF. It doesn't matter what I type here, numbers, letters. It doesn't seem to go anywhere, probably unless I get the right answer. So I'm just going to Control C out of that real quick. And let's go ahead and run strings on it. Strings gives me a good idea of what's in this particular file. Just pulls out any strings. I think it's like length of 5 or greater. So it actually pulls out 3 strings, which almost gives this one up because it's actually does give it up. So we got what's my name, which is the first thing that comes out. Obviously, there's a you got it if we get the answer right. And then there's this other MRMTG right here, which we don't really know what. I could probably take a guess as to what that is. It's probably the password. So just to kind of show you that this one's super easy, but we're gonna break this out into another program here in a second. So if I were to go back into guest name and I type MRMTG, you got it, right? So pretty easy, but you know, a lot of times they're not going to be this easy. So I'm going to jump into another program here, a debugger, disassembler, so we can kind of see what this looks like and kind of just understand the logic of why this is working this way. So the one I like to use lately, I've been obsessed with Cutter, which is kind of similar to Ghidra.
Yeah.
But it's also got it does have a debugger in it, but it's a little wonky, so it's still in beta, so I don't usually use that too much. But the disassembler is actually using Ghidra's disassembler as well. So I'm going to go ahead and load this up. I like to just use the default settings. No, not really any point in these to go and do anything different. All right. So the first window that it actually pops up here is the decompiler, and the decompiler is going to just basically take all this this code and try to make it into a C program again for me here. And you can see it actually did a really good job here. So we can see here's the C program. We also have our functions listed over here on the left. A lot of times I'm going to be looking for a main function to jump into, just like any other C or C++ program. You want to try and find where the main block of code is and where everything kind of goes from there. But in some of them, you don't have a main, you just have an entry. So entry 0 is okay. So we're just going to start off here. We got our main function right here. Got a couple of variables being declared. We see them using puts, which is just going to put something out to the screen. So we see it just putting this this particular piece of ASCII out to the screen. And then it's doing an fgets right here, where it's just pulling in a string, and it's also looking for, I believe this is just a length of 6 is what it's reserving for that. And then it does a string compare between what it is that you inputted there and that MRMTG. And then just basically, as long as you're not getting the answer to this, then it's going to keep looping through. This is just a do while loop. So as soon as we actually get this proper string compare, this will set to 1, and then we get it. So a couple other things that are interesting in here. Disassembly view. Disassembly is actually going to break this out into assembly for us, so we can take a look at what it does. This is another reason why I really like Cutter, is it actually gives me my assembly language right here, but it also does some other translations for me here as well that makes it really easy to understand what it is the assembly is doing. So it kind of gives you this like kind of pseudo C code over here so we can see what's happening. So we can kind of see right here where we're just kind of prepping the stack. We're moving our base pointer and our stack pointer, getting some room to put everything in. We can see right here that it's loading in the effective address right here. This starts with it's a hex address. Ending in.
So Taylor, maybe you can explain a little bit what is a base pointer and what is a stack pointer?
All right, so when we're putting the program into memory, it's basically got we have to make room on the stack. So we got the base pointer of where the base of the stack is, and then we have the actual pointer where we're at. So it's going to basically, it needs to push the stack up so it can create room, and it's resetting it. So it's a lot of times what it's going to do is it's going to make this extra room for you, and it's going to back up what was already happening. So where we're at right now is we're at the point of just prepping the stack. Nothing actually has happened in the program yet. We're just making a little bit of room in memory for it. And then, of course, it's loading this into memory right here. So it's loading this address or whatever's at this address here. And we know what's at this address because it's telling us here. But a couple other ways we could tell is if I were to take this address and then I were to go look in, say, strings, I can actually match that address, this F8E, to what's my name. So we can see where it's coming from. And then we can see where it's putting it to the screen. And it's actually, once again, it's translating this for us. It's saying I'm using this imported function puts, and I'm going to put this this constant character string here, which is the what's my name, into that. So without going through all of this right here, you can kind of see that it does break it down pretty simply for us. There's one other section here I like to look at they got, which is the graph. The graph will give you a really good idea of the program flow. Yeah. So we'll use this a couple of times. And this right here, I like this. In this example, and this is one of the reasons I like to do this one in here, is not because I want to solve it, but more because it really does show what the kind of the power of this particular decompiler and disassembler. So we can see where our initial pieces here, where it's putting this what's my name there, and then we go into our do while loop, and you can see that by the arrows here. So once we get into this section here, we have a jump not equal at the very bottom. You can see when I clicked on it, it actually highlighted that green arrow there. So this is basically saying if we get our answer wrong, it's going to jump back to the beginning of this code line right here. And until we actually get this jump not equal, then we'll jump down to the bottom here and actually get our you got it. So yeah, that's just kind of a little breakdown of what this first one is doing.
So Taylor, I notice once you succeed, it goes to that last bit of code. Looks like it's loading string you got it into RDI. Does it tell you what that string is? Like can you see the content of that string?
You're talking about right here?
Yeah.
With the got it? Yeah.
Yeah. Can you show us how to like follow that in memory?
Yeah.
In case it didn't just show up when you ran strings.
Right. So, yeah, the you got it right here, where we're getting this load effective address. So load effective address is basically just taking whatever this address right here is, and it's loading it into RDI. So if we were to follow this in a debugger, we would actually see this address right here get put into RDI, and then we would see puts actually call that string there. So if we wanted to see this you got it string, we could actually just look at this address right here, the 1 FA3. And since I'm not running the program right now, I'm going to have to just directly reference my strings.
Gotcha.
Once again, I jump over here, and we get a you got it. Is where that's at. And actually, you can tell here's the 3 strings that are in the text field of the program itself. You can see it does actually label where it found them as well.
Right.
Click out of that. So sometimes you'll see them in the text file. Sometimes you'll see them, or the text portion of the file. Sometimes you see them in other places, but let's give you a good idea of where it found the string as well.
Okay. And again, for those who haven't done much assembly, what is RDI?
So RDI is one of the registers that you can put data into. So I'm going to show you a little bit of that once we get into the debugger. Unfortunately, it doesn't show me any of my registers in here.
Okay.
We could try doing an emulation, but I don't know that that's going to work on here. But we'll get into that. I'm going to show you where we can actually play with those. I'll probably be using Evans Debugger, which is very similar to GDB. It's just a graphical interface, a little bit easier to work with.
Yeah.
If you're not a huge command line person, then it's easier to show. So let's jump out of here. We're going to go work on the next, the other Mac OS one, since this one's pretty easy. I really just wanted to give you kind of a tour through the app that I'm going to be using for this next one here as well.
Yeah, definitely. Running strings is always the first thing I do on any kind of static analysis, whether it's a Crackmes or malware that we're looking at. Just run strings and you can get a lot of interesting stuff. Sometimes in a Crackmes you'll just get the answer. With malware, most malware nowadays they're usually packed, and they're trying to hide the data inside of it. But occasionally you can just run strings and you'll actually get, CNC servers and IP addresses, various things like that you can use to detect or find the malware.
Yeah, a lot of times they're not really trying to obfuscate a lot of this stuff. And in the Crackmes, we'll find there's a lot of people are trying to do a lot of techniques to hide a lot of this data. And we're going to find that actually in this next one here, that it's not going to be as easy. So this one here, when I run it, you can see I don't have any kind of output that's coming out of this. So this more than likely means that it's going to take some kind of argument. So let's just try giving it 1, 2, 3.
Before we get to that, Taylor, what are you smoking today?
So, yeah, a little story there. I actually had a nice JR cigar that I was going to smoke, and I have a kid who is 2.5 and found my cigar on my desk and broke it into pieces. So I am smoking a 2020 Black and Mild. It's quite delicious. But nothing fancy from my side today, fortunately. I should have prepared better. So let's see here. So a couple other things we could try to do here.
I'll tell you what, I'll send you some of these undercrowns.
Oh, dude, I would appreciate it. Let's see here. Let's try putting in some more values, just see what it does. So here's another thing. We're getting another string out of this buffer overflow. Now, that's kind of funny because it's probably not a buffer overflow because we would actually get a segmentation fault if that were the case. Yeah. But that does tell me that it's looking at the length of the string that I'm putting in. And if I go over a certain length, it's probably telling me that I'm going too far. So I could use that to try and actually find the length of it if I wanted to do that. Maybe just kind of shorten it, keep shortening it, kind of find wherever it. Okay, so we're about there. All right, so it's looking for a, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's looking for like a 9 character. Is that 9? Yeah, I think it's about nine characters, right? So anyway, let's go ahead and run strings on it and see what else we can find there. All right, so this one actually does give us like our 3 statuses that we can get back, right? Correct, something went wrong, or buffer overflow, but I don't think any of these are the actual password. Doubt correct is it. So at least we know now that it's going to take an argument. We know that it's going to take an argument of a certain length. And I don't believe it may take more than 1 argument here. Nope, it doesn't know how to handle that. So that's fine. All right, so let's go ahead and just start up Cutter again, kind of same process. I'm going to kind of take a look at what, I'm just going to use the defaults here. We're going to take a look at what we can find for just the, let's look at the decompiler first, right? Let's try to just translate this into something easy to read. And this already did it for you. And like I mentioned earlier, this is actually using Ghidra here. So if you use Ghidra, you're going to get pretty much the same thing. I've noticed one of the things I like about Cutter a little bit more than Ghidra is it actually gives me the proper main function, which translates this a lot easier than Ghidra usually does.
Yeah, if you guys were watching a few weeks ago, we had Jason on here looking at Crackmes, and he was using Ghidra, but that was the first thing he did every time he looked at the decompiler, was having to change the strings to clean up the code.
Mm-hmm. So this one, it does a lot of that for you. I don't have to go in here and tell it that it requires arguments. But that is a very important thing for this one, is this one does take in arguments. So you can see up here the main function takes in 2 arguments. One is the amount of strings it's taking in, and then of course a pointer to the strings that it's taking in. We can also see the variables being declared up here, which all have unfriendly names, which is fine. Most of the time, those do not translate over, so we don't know what they're going to be. We just kind of have to look at them and figure out what they're doing. So going down a little bit further here, not going to pay too much attention to this, is just setting a couple of variables to 0. But it is important to note that neither one of these variables look like strings to me. These are both integers, right? Or potentially integers. So first thing that it looks like it's checking is to see if arg1 equals 2. For anybody who writes any code, pretty much all that means, is that we're looking for 2 arguments, including the name of the program. So you're going to have 2 different arguments. This one's going to be with passver, and then whatever our password is that we're entering with it. But if it doesn't equal that, then it just returns 0, which is why when we run passver, it just dies out. Is because it's not actually getting anything after that. It just goes to return 0 if you don't provide an argument. Or if we provide too many, as we showed earlier, it just errors out. It tries to do the same thing, but it didn't know how to handle the second argument there. So right after that, we can see that it's checking the string length. So if you're not familiar with any of these like C program functions, you can always look these up. Really simple to do. All this is doing for this one is it's taking in a number, or it's taking in a group, and it's trying to figure out how many arguments that we have. So we have, or how long the character that we have is. So argument 2 we see up here is pointing to our string. So we're taking the first argument from that, and we're just trying to figure out how long is this string. So this goes back to where we were, if we typed in something too long, it did a buffer overflow. So it's saying if this string is less than 10 characters long, say buffer overflow, and then exit 1. So that's how we know that that's where that's actually coming from. Now the next portion of this here is that it's going to do a string copy. So it's going to take those that space of 10, and it's going to put that argument into this variable here, this var ah. And keep in mind again, this var ah is actually a number, not a string. So this is more than likely going to take some kind of number or something like that potentially. So going down just a little bit further, this one actually threw me off a little bit, and this is where you kind of need to get into reading the manual, right? RTFM. Yeah. If you don't understand what it is that something is doing, don't be afraid to look it up, even on something really simple. So for this one right here, essentially what it's doing is there's an and happening here. I'm not even paying attention as much to like what's being declared up here, but more just the fact that I'm taking this var ah, which I know is my password that I'm entering, and it's doing an and on it against this hex. And it's basically trying to see if I do an and between these two, it needs to equal 60 or hex 61. So another thing I usually look for, if I'm looking at hex values, and especially if they're like 2-digit values, I'm usually going to try and translate those into ASCII. They probably have some kind of ASCII representation to them that's being represented here. So quickest way to do that, if we just pull up a terminal, we can just man ASCII.
RTFM, that's what I always say.
Yep. And then, so this will give us our different, let's see here. This one's listed a little bit different than the one I usually use. Back down. All right.
You have to use your arrows on your keyboard to scroll around on the man page.
Yeah, I know. It's like, trying. There we go. All right, decimal set. Hexadecimal set. We're looking for 61. Then that would be a lowercase a. Right? So right here it's saying if we do this and if we also notice the difference here is this 7F right here. So it's probably like the first character that it's looking to see as 61. So that tells us right there that that's actually our first character is going to be, second here, let me just delete all that. It's an A. So we know the first character of it needs to be an A. So then we would get down into this next part right here. And this is where there's a little bit more confusion, right? Because it's going to do another string length of the same character, which we did earlier, right? Where we were saying, well, it needs to be less than 10. So we think it's a character that's going to be like 9 characters long, right? Because this is a less than 10. But it's actually looking for it to equal 7. So it needs to be a 7-character password. And it needs to start with the letter A. And it doesn't seem to have any other checks that it can do here. So let's just see if we can make that work. Oops. Pass version, and then we'll say A 1, 2, 3, 4, 5, 6, 7. Oop, now we're 7. Correct.
Nice.
So it doesn't really matter what these characters after it is. They can be anything, right? As long as it's 7 characters long and it starts with an A, then we got it. So don't need to spend too much more time on this one. A lot of the same things you'll find here. The strings section will give you those 3 strings. And there's not a password that's written in there. It's just looking for patterns that we're giving it. So you can't just directly do a string compare on this one. You really got to kind of read through it. You could go through the disassembly on this one and try to walk through it. I just find it's much easier to just read the decompiler and do it that way.
Awesome.
Right. So that's it for the Mac OS ones. Let's move over to Linux. Just close that down. And I have, so I actually use Parrot Security as my OS of choice on this. I know a lot of people like to use Kali. I used Kali for a while, but I switched over to this because I was having issues with my updates for a while and kind of fell in love with this OS. So we're going to just stick to this. All right, so on this one, I have some on my desktop. I got some Crackmes in here. I got 3 of them. We're only going to touch 2 of these. That auth one I'm still working on something else, but Guess Me right here will be our next one that we're going to do. So first of all, just kind of starting off again, let's do a file on Guess Me. You can see that this is an ELF file, so we know it's a 64-bit Linux file. And then we'll go ahead and run it. All right, so this one, once again, it doesn't take an argument, or it may take an argument, but it doesn't seem to have evaluated anything there. And then we can put in a guess, and it'll actually drop out. This one doesn't do like an infinite loop like the last one. So we can see if it gives me anything different. No, it doesn't really seem to care about size here either. But we know a couple of things. We know that it's going to give us like a put for your guess. It's going to do a put for sorry here. So we know the direction this program is going to go if we get it wrong, right? Is it's going to go in the sorry direction. So we want to just avoid that. All right, let's go start up Cutter here. And we're going to go ahead and launch Guess Me and just keep the defaults. It's fine. All right. So this is going to be a little bit more code than what we were looking at before. You can see this one's quite populated. I have a little bit of a different setup in this one than you probably saw in the other one, or when I was on Mac. So this one actually, or in Cutter, you can move these windows around. That's another thing I really like about it is that you can see I have my strings right over here. I can actually click on this and I can move it around and put it wherever I want to. So I like to have it over here where I can just kind of quickly reference it. And there's actually a separate view for the debugger if you decide to use that. All right, so let's just jump into our decompiler, see what we got going on. This right here, so you notice we're in entry right now, so not a lot of code here. Let's just jump over to main. All right, so this is the main function. Like I said, quite a bit more code here to go through. And then if we scroll on our left here, we can see a few other things. All these blue functions right here, these are all just imported functions. So we can kind of see what different capability the program has, as well as any other functions that may be a part of this. All right, so looking at this is a lot of code, and I'm not going to spend a lot of time kind of trying to go through this code. I'm going to teach you the way to be lazy and just get to the flag, right? Like, how do I think about this when I just get a ton of code in front of me? And the trick is to focus on the calls and focus on the jumps that the program's actually using. So let's jump into graph view here again. You can see there's this giant, big old piece right up here where it's starting off. And then I got this really big division right here, which, let me see if I can zoom out of that baby. I think I can. Zoom out a little bit, maybe. All right. Okay, there we go. So you can kind of click and drag around in this, but I just wanted to see kind of the big picture, is that we start off, we get all the way down here to this little section right here where there's a jump not equal. And then if we take the jump, then we go to this section right here. If we don't take the jump is not equal, or jump is equal, then we're going to go down this path right here. So what I want to figure out is where's sorry? Where's the part where this program is going to tell me something's wrong? So I can tell right here that regardless of which direction I take here, there's going to be a C out instruction that happens here, and we're gonna basically load some variable into RSI, and then we're going to see a C out on both. So what I want to do is I'm just going to go reference these strings. I got a 21A and I have a 2020. So if I just go look over here, and I'm sorting these by where they're at, so I can actually see. Sorry, at 2020, it's actually picking it up kind of wrong here, where it's 2021. But I know that 2020 is going to be that S right there, so that's where my sorry is. So I know if I take this direction right here, that's the wrong direction. I want to take this direction over here. And then, like I said, I don't really care too much about what this code does right here. I just know that that's the direction I want to go. So what I want to do now is I want to trick the program. I don't need to know what the password is. I can simply just tell it once I'm running through the program. I can either flip this right here to where it'll jump to where I want it to, or I could just change the value itself. But to do that, I'm going to use a different program because I think I said this earlier, but I do have some issues running the debugger in here as it is in beta. So we're going to use another program to do that. So I'm just going to minimize this. And we're going to pull up trusty Evans debugger, or EDB. This is usually going to be installed on Kali by default or Impaired as well. All right. So a little change of pace here. We're not in dark mode anymore. All right. Mostly because dark mode in this is quite ugly. Yeah. All right. So we're just going to load up Guess Me. So this one is going to be kind of similar. We have some of the similar views. We have our disassembly up here, which we're going to be actually walking through. Bryson mentioned this earlier, but we also have our registers over here, so I can see all my different registers. We were talking about like RDI and stuff like that. These are my different memory registers.
Can you give us a quick rundown of the registers and what they are?
Oh, gosh, if I can remember what they all mean, but yeah. So a lot of these are just going to be like RAX, RCX, RDX, RB. Like all of these right here are just kind of more your general purpose registers. We also have our stack pointer and our base pointer. And then let me see here. Does it? I was looking for RIP. Did I miss it? Oh, there we go. And RIP right here, this is our index pointer. So this is where our CPU is currently pointing, or the instruction that it's currently pointing to do.
So if you haven't done any disassembling, a good resource, and it's pretty dated now, but it's still a good resource, is Smashing the Stack for Fun and Profit by Aleph One. It was originally released on what was it? Some webzine. What was it? Was it Frack? But anyway, in the 90s, it's 32-bit, so these registers are slightly different. So like RAX, RBX, they are EAX and EBX in 32-bit, and you can actually still use those to reference the lower 32-bit portion of the 64-bit registers. But it's all about finding EIP, or in this case RIP, if you're trying to smash the stack, which is basically all about buffer overflows. And that instruction pointer, being able to rewrite that and control the flow of the program, so you can cause a buffer overflow and execute the commands that you want it to. So it's a good primer on just kind of learning how the stack works. There's a pretty good explanation of how the stack works and the registers. Just keep in mind that's how in 32-bit all the registers start with an E. In 64-bit they all start with an R. So newer applications, it's going to be slightly different.
And there's also going to be a bit of confusion added in there too, because sometimes you're even going to see in here that they're going to refer to the 32-bit registers. So right here I see EBP being referred to, whereas I have an RBP, but I don't have an EBP. But if I go over here and I double click on that, you can actually see here's my 64-bit version, and here is my 32-bit version. So if this was like maybe written more in 32-bit, then you may be using the the EBP. You've
also got the 16-bit and the 8-bit version there as well.
Yes.
Which, yeah.
So on this one right here, what we're going to do, I'm going to go ahead and click play once. And what this does is actually brings me to the entry right there. And then if I scroll down a little bit, you can kind of see some of the references that we were looking at earlier. Here's my my ASCII string, your guess, which is being loaded in. So same code, right? I don't have all that cool pseudocode that I had on the side really telling me what it is that this is doing, but it's the same program. So what I'm really looking for here is that jump again. We can see the jumps also being represented over here by these little arrows. So it's actually showing, like, if I were to take this jump not equal and I follow this down, there's actually a place that it winds up. So what we're going to do, though, is we're going to override this jump here. And the way that we're going to do that is I'm going to set a breakpoint right when this comparison happens. So I'm just going to go here. I'm going to toggle a breakpoint. All right, we can see my little red dot right there, which is just showing that I have a breakpoint. I'm going to pull up my little console here as well.
I think it's also worth noting that what you're doing here, this looks very similar no matter which debugger you're using. I mean, unless you're using GDB straight from the command line, it might look a little bit differently. But if you're using Ollie debug or WinDebug or x64 debug, this interface, setting the breakpoints, showing the jump with the arrow on the side, all that looks very similar. So, there are differences between them, and you find one that you like and you use it most of the time. But for the most part, this view where you've got the assembly code, you've got the actual dump in memory there on the bottom, you've got the stack on the bottom right, and then you've got the registers on the right. That is very common and kind of like the standard for most debuggers when you open them up. So this, whatever you're using, it's still going to look very similar to this.
Absolutely. Yeah, I actually debated on kind of what I was going to use. I decided to use EDB mostly because it's so much easier to view. You have all of your stuff in front of you. GDB, you got to kind of make watches for these things and type them out. So I think it's a little easier to follow here. But yeah, so now that we got our breakpoint, we could step through the program. A lot of times when you're trying to figure out what a program does and where values are getting moved, you can step through them. So kind of a little like tutorial here is that I usually do a step over. So step over instead of doing a step into, because I don't really need to know what certain functions in here do, right? Like I don't need to know what a puts does. I don't need to know what a string copy does. Those are going to be standard. So I don't want to go into that. When they make that call, I don't want to follow that. I just want to go over it. So I'll use step over when I'm going
and it's still
through this.
executing that code. It's just not, the debugger itself isn't walking you through every step along the way.
Exactly. So we can kind of step through it. But what I'm going to do here is I'm actually just going to tell it to play. So we got our breakpoint. It hasn't hit our breakpoint yet because it's actually waiting for me to input a guess. So I'm just going to put in my guess. It doesn't matter what I put in here. In fact, so there's another thing about this is that I didn't really go through too much of this, but there's a function in that beginning block of code before we get to this that actually is looking for things like getting the current time of day and things like that. So it's actually doing something where this password is going to be different every single time. There's not an actual like password that you can guess here unless you're just that lucky. And we're going to see that here in just a second. So we just hit our breakpoint after I put this in. We're now sitting right here at the comparison. And down here, it gives me a little description of what I'm actually looking at. So we have a comparison between EAX or whatever is in EAX. And if we go over here to RAX, open this up, you can see that I entered a string and there were no, it didn't evaluate that very well here. So we can see that EAX is actually just all zeros right now. And then we can see RBP minus 70. This is just a place on the stack. So when you have memory randomization, not going to go too much into that, it's going to refer to certain places where it's at to where the code's going to be. So it's actually saying at my base pointer minus 70 hex is going to be where it is that my value is going to be, right? Or where my pointer is going to be. So I have my address at that location. And then at that address there is actually the value here, this hex value of C47EB. So what I'm going to do is, instead of trying to like change an instruction here or anything like that, because that can get, you can usually just, I can come in here and I can say a jump equal. But the problem with changing instructions and things like that is that you can also sometimes change the actual number of bytes that you're using for these instructions. And if you change that, that can throw off these references that are being made here. So instead of trying to change or patch the program to just jump a different direction, I'm just going to fill the value of EAX with whatever is at hex 70, so they'll actually match and be equal and take the jump that I want them to take. So the way I'm going to do that is I'm just going to jump into RAX here. And since this is a 32-bit value right here, not a 64-bit one, I'm going to use this portion right here, 3C4 7EB, right? Cool. And now we can actually see it's set to that up here as well. And now what I can do is I can step through this, right? I can go ahead and just kind of, let's do it. And we'll see that this time it's not going to make that jump there because we actually did have an equal value. So we're not going to make a jump. We're just going to go in the next part. And I could walk through this and I can try and figure out what this is doing. But instead, let's just let it run the rest of the way through by hitting play. And we can see that it exited normally. So the program finished. And if I go to my debug here, it looks like it spit out a flag there. So essentially, I didn't have to know what a lot of this program did. I just needed to know where it was making decisions, and I just want it to make the right decision. I don't need to know what else it's doing. Yep. So that's the whole point of this one, is that even when you get really big and long programs like this, a lot of times it's about switching a bit or changing a value somewhere to get it to do what you want it to do. All right, so let's hop back over to Cutter, and we're going to do another one. I got one more to show you. All right. So now I have a globe. So it's actually meant to be something that's like a taking in some kind of key, right? So if I run this here. So here's another like kind of pivot point we can see is that I get this usage right here if I just try and run the program, and it's asking for a key, like a serial key or something like that. So we know that it's going to take in some value here, and we know that if we get it wrong, we're going to get this wrong key, try again, right? And we can try making it longer, be consistent, and not much there. We can also run it through strings and see what else we get here. Sorry, bro. We got puts, so we're going to see a lot of different things in here. You can see it's actually importing string length and puts and a few other things. We can see that it does have nice one. Now can you key gem me? So okay, that's probably what I'm going to get if I get success. And there's some other values in here that could be strings, maybe not. But yeah, a little bit of hints there. We do know that there at least is a success message if we get everything right. So that's cool. All right, so let's go ahead and just go back to well.
Looks like Oxbrone in the chat says good morning. So good morning, Oxbrone.
Good morning. All right, same as usual. Just going to load this up, take the defaults. All right. Okay, so let's see here. Let's just go ahead and try to look at this in our decompiler first. And we're going to switch over to our main function again here. All right. So this one, once again, our decompiler does a lot of our hard work for us and really translates this down into C. So at this point, it's really just about reversing the C here. And since this is like it's taking in a key, and we do know that it wants us to create a keygen for it, then we know that it's not going to be just some value that we're going to string compare. There's going to be some kind of pattern it's looking for. So this one we're going to use a lot of our string section here, and I'm going to show you one other thing, which is that this sorry bro function right here. If we look over here in our functions, we can actually see this sorry bro function in here. Click in there and see what that does as well. So just kind of going through this, puts right here is putting a hex address right? So this is going to be our string that we're putting out, and we can reference that on the side. So we can kind of scroll down here. Let's see here. So it gets us this wrong key, try again, right here. So I don't even really need to know what the rest of this does. This is obviously where I don't want the program to go, is into sorry, bro. So let's just kind of start from the beginning here. So the first thing it's going to do is it's going to put out the string 848. So if we look at 848, that would be our usage. Sorry about that. Dog wanted to go in. All right. So it's going to put in our usage, assuming that we provide it less than 2 arguments. So this is kind of similar to that other one where we saw equals to. This one's just basically saying, if you give me less than 2 arguments, then then we're going to give you usage. So it's expecting that we give it some kind of key afterwards. Then it just kind of jumps into an else here, and we can start building out what it is that our key is going to need or going to require. So let's open up our little text here so we can start making some notes. So we know the first thing it's going to do is it's going to compare our string, not compare our string. It's going to get the string length and put it into variable 1. And if variable 1 does not equal 5, sorry, bro. So we know that it needs to be 5 characters long. All right. Now the next piece here is that it's going to take a look at argv1, and argv1 is going to be the actual string that we give it. So we give it our key, that's going to be argv1 here. And then it's looking in the first part of that string, right? So like if we take a string and divide it into characters, then place 1 right here needs to equal an @ sign. Because if it doesn't, sorry, bro. So we know that at least the second character needs to be an @ symbol. And I say a second character because obviously this starts at 0.
Yep.
So if we were to go, wrong window. Let me find my, there we go. Okay. Okay. So it needs to be an @ symbol. All right. And then the next part right here, it's saying that we're going to add up a couple of different pieces of this string. So it's actually taking an integer value. So you really want to pay close attention to the type that it's giving you here, right? So I have a 32-bit integer of the 4th field plus the 2nd field plus the 3rd field needs to equal 300. So that's kind of interesting. If this is a like a numerical key, I can't take three different characters and add them up to 300, right? I mean, like, what do you think I should do here? I would think that I probably need to find 3 characters that can add up to 300.
Yep.
So let's go back here. Let's make some more notes. All right, so we know that 2, 3, and 4 positions need to add up to 300 decimal. And that's the key here, right? Is that whatever I put in here, this can take in a string, but whatever I put in, it's going to make it an integer. It's going to find an integer value. So let's take three different ASCII characters that add up to 300. Find out what ASCII character is a decimal of 100. And we'll just open up a terminal. Let's get a new window.
This is the decimal value, right? Not the hex value.
Exactly. Yeah, because the hex value would be a little bit different. But right here, since we're not putting an OX in front of it, then we're not looking at hex. We know that it's going to be a decimal value that we want to see. So let's find the decimal value of 100. D. And you can also tell these are in order, right? If I wanted to keygen this, then I could probably add up multiple different numbers here to equal 300. But we're just, in this case, just to make it easy, we're just going to use D. So let's make one more note here. D equals 100. All right.
And when you say the second, third, and fourth, you're actually, since we're starting counting from 2, you actually mean the 3rd, 4th, and 5th character, right?
Exactly. So that's another thing. So let's go ahead and let's make a test key here, right? Let's say that my first field will be 0. The second character needs to be an @ and then I need to, and this needs to be 5 characters long, and in position 3, 4, and 5, I need to have something that adds up to 300. So 2, 3, right? So all right, so this right here, let's see if this works. And just try to paste that. Nice one. All right, cool. So that worked. And the cool thing is here is that we could actually change this up. It doesn't really matter. But C, D, and E would also still add up. Right? So we could do, as long as they all add up to 300, then that's going to work. But as soon as I like that, that's not going to work. So we could keygen this. I'm not going to really go into keygenning it, but yeah, that's the basics of it there.
Nice. All right.
Cool.
Was that?
And that's all the Crackmes I got, man. I think I'm out.
Well, thanks for going through that, Taylor. That was good. That was some good content there. If you guys want to practice some more Crackmes, that was on Crackmes.1, I believe was the site.
Crackmes.1, and yeah, they actually, here, just kind of show you this. They have especially if you're just starting out, they got a really good search feature in here. So if you're really not sure, kind of like you're on a kind of a lower skill level, just kind of get started. We go to Crackmes.1 here. You can just go up here to the search and then choose something like easy and very easy, you know, and then maybe something that a language you're familiar with, right? Maybe you're familiar with C, and then you're on a particular platform. Maybe you want something for Windows or whatever, and it'll give you everything that matches that. And there's plenty of them in there. There's all sorts of things to practice on.
Nice. They even have Java. My daughter's taking Java, and I haven't worked in Java in about 15 years, so she's always asking me for help with her homework, and I'm trying to remember how Java works.
Yeah.
Yeah. All right. Well, thanks, Taylor. That was some good stuff. Like I said, if you guys want to try out some more Crackmes, Crackmes.1 is a good source. There's also a lot of other sites out there that have some, but it looks like Crackmes.1 has a lot to choose from, and some good resources there. If you want to look back at some of the other Crackmes we've done, a couple weeks ago, I had Jason here from Jason Slagle from CNWR. He went through some of the Crackmes that we had done in previous CTFs. So there's also some good content there. Yeah, so Crackmes are fun. They're a good way to learn how to reverse engineer, which is a nice skill to have. Comes in handy in a lot of things, just depending on what your role is in security. If you're doing exploit development, it's very useful. You know, you got to smash that stack, find those buffer overflows or other exploits. Or what I've been doing lately is malware analysis. So again, those tools come in handy there as well, or just Crackmes and CTFs. Or you know, actually making a keygen for a game. Don't recommend doing anything illegal. I think I have to say that, but that's also an option. Speaking of games, I do have some plans coming up. A few weeks ago, I showed you a proof of concept of something that I'm working on that won't be ready for a while. Sometime next year is what I'm hoping for, but there's a game that I'm working on called Hacker Die, which is a game that you will not be able to complete without hacking it. So you're going to have to do some reverse engineering and crack that, or there's some useful tools for creating cheats in games. I think Cheat Engine is what I used in my demo. It's got some pretty useful tools. I might give you a demo of that. Actually, I think next week that might be a good topic to go over. I haven't actually planned anything out for next week. I think that'd be a good one. So yeah, next week we'll take a look at Cheat Engine and how you can use that to you know, write some cheats for games. So it's a pretty useful tool. It's got different functions that make it easy to find certain addresses in memory, such as where your position is or what your health is in a game, and ways you can modify it. It's got a nice little tutorial that kind of walks you through how that works as well. So that's something to check out. And then I haven't set a specific date yet, but I'm looking in December. I'm planning on putting together a CTF that's also going to be video game based. So I don't really think Hack or Die will be ready by December. I'm actually looking probably mid 2021 or 2022 or something like that. Before that's going to be really ready. But I found a number of open source video games that have some vulnerabilities, and I thought they'd make some nice challenges. So I've got an FPS, a old-fashioned Mud. Mud is a multi-user dungeon. They used to play on BBSs in the early days of the internet. There's still some of those out there. Looking at some others, I'm trying to find a good MMO that has some vulnerabilities, and probably have 3 or 4 different video games that will have servers up. You can actually play them, but all of them will have exploits, and you can exploit them. So that's coming up. We'll probably try to live stream through the whole CTF, and I'll try to get some guys together, and we'll be playing some of the video games and seeing how that works. I just another disclaimer, I'm not great at video games. I don't play often. I'm usually too busy doing other stuff. This kind of stuff. So we'll try an FPS, but I will probably lose a lot. But and there's a good chance we'll have people crashing the server while we're playing as well, because they're going to be trying to exploit it. But yeah, that's coming up in December. Next week I'll walk through Cheat Engine. We can see how that goes, and I think that is it for now. So thanks for everybody who's watching, and I hope you learned something. I think Taylor did a pretty great job, so thanks again, Taylor. And love the shirt.
Yeah, I like it.
Yeah. Yeah, we'll see you guys next week. Don't forget, if you're in a CTF and you ever get stuck, to try harder, don't panic, and always RTFM. See you later.
It's a madman, the mountain's fire.